Let me describe how my day's gone so far. I woke up fairly early, and I wasn't feeling very good. So it's kind of gone down like that. And then went down and got me a pop. And that always makes me feel better. Came back. I started recording. That made me feel better. And I'm still recording. I'll probably have to go out pretty soon, maybe do a little bit of work, maybe. If I do a little bit of work, my day's going to shoot down like that. Come back, and if I do a little bit more math, that'll go up. Let me see, TV tonight, there's no Big Bang Theory, so that's going to go down. Let's see, nothing good on TV, and so that's how my day's going to go. There's no way we can get a graph to fit that, but what we can do is we can break these into pieces like this. Now by breaking it into pieces, I can get a model for this piece right here. Maybe this is y is equal to negative 2x. I don't know. Maybe this piece right here is y is equal to x. Maybe this piece right here is y is equal to 1/2 x. So by breaking it into pieces, then we can model it. That's a concept of piecewise functions. We can never get something to completely model our data, but we can break it into pieces, and we can. Okay, so these first ones are just evaluating. So let's take a look at those. We've got f of x is equal to 9x plus 2 and 8x minus 1. It says if x is less than 2, and this one says if x is greater than or equal to 2. And let's find part A. We want to find f of negative 5. Now remember from before, whatever number's inside the parentheses here is your x. So they're basically telling you x is equal to negative 5. Now our piecewise function up here says, this is how it's written, 9x plus 2, it looks like that when x is less than 2. Now it looks like 8x minus 1 when x is greater than or equal to 2. Well, if I come down here, I got negative 5. You look to first your conditions over here, and you see where does that fall at? Is negative 5 less than 2, or is negative 5 greater than or equal to 2? Well, it's less than 2. So I'm going to plug it into this first piece. So I'll take 9 times negative 5 plus 2. That gives us 9 times negative 5 is negative 45 plus 2, which gives us negative 43. B is f of 2. Now again, whatever number's inside the parentheses is our x, so they're telling us x is 2. And we're going to look up here and look at our conditions. And you're trying to see where it falls. Is 2 less than 2, or is 2 greater than or equal to 2? Well, it's not greater than, but it is equal to 2, so it's going to fall into our second piece. So that's where I'm going to evaluate it at. So I put the 2 into the 8x minus 1. And that gives us 16 minus 1, or 50. Grab a drink. And we're finding f of 8. Okay. Again, the number inside the parentheses here is your x, so x is 8. We're coming over here to conditions. Is 8 less than 2, or is 8 greater than or equal to 2? Well, it's greater than 2, isn't it? So it's going to fall in our second piece. So we'll plug the 8 into the 8x minus 1. That gives us 64 minus 1, or it gives us 63. Now when I put these on a test for evaluating a piecewise function, if you plug it into both pieces, I'll take every point off. The goal of this is not for you to show how good you are at evaluating a function. They're usually pretty simple to evaluate. The big goal of it is for you to figure out which piece to plug it into. not to plug it into both of them. That's not like double the work so you get double the credit. You get 0 credit in my class. Let's look at another one of those. So we got h of x is equal to 7x minus 1 over x plus 2 and then 4. So it looks like this when x is not equal to negative 2, and it looks like this when x is equal to negative 2. Our first one, we want to find h of negative 5. Again, whatever numbers inside of parentheses is our x, so they're basically telling us x is negative 5. So we come up here and compare it against our conditions. Is negative 5 not equal to negative 2, or is negative 5 equal to negative 2? Well, it's not equal to, so we're going to plug that into our first piece. So again, where our x is, we put in parentheses, and we're going to plug in the negative 5. Well, 7 times negative 5 is negative 35 minus 1. Negative 5 plus 2 is negative 3. That gives us negative 36 over negative 3, or it gives us positive 12. Okay, h of negative 2. Now again, whatever's inside your parentheses, it's going to be your x. So they're basically telling us x is negative 2. So I'm going to come over here and compare it against my conditions. Is negative 2 not equal to negative 2, or is negative 2 equal to negative 2? Well, it's equal to negative 2. So we're going to plug into this piece. This is actually so simple it's hard. There is no x to plug into, so actually our answer is just 4. Let me do c over here. C is h of 4. So, my wife. So I'm going to be disrupted by her and lose my train of thought. Let me see, what am I doing? Okay, h of 4. Again, our x value is what's inside of parentheses, which is 4. So I'll come over here, compare it against my conditions. Is 4 not equal to negative 2, or is 4 equal to negative 2? Well, it's not equal to negative 2, so we're going to plug it in our first piece. So I got 7 times 4 minus 1 over 4 plus 2. That gives us 28 minus 1 over 6. Gives us 27 over 6. And this reduces. Top and bottom both divisible by 3. So that gives us 9 over 2. So 9/2 is our answer. Let's look at the next problems after my tablet gets done blowing up. There we go. This is a graphing one. Got f of x is equal to x minus 3, x plus 1. And this one looks like that when x is less than negative 2. It looks like this when x is greater than or equal to negative 2. And this is graphing piecewise functions. Okay, our first step. Graph each piece separately. So graph each piece separately. So we got y is equal to x minus 3, and we got y is equal to x plus 1. Now you could graph these in whatever manner you see fit. Y is equal to x minus 3. Okay, that's shifted down 3. And looks like that. Okay, y is equal to x plus 1. That's up 1. Looks like that. Not that can't draw straight lines, but then step 2. apply your conditions. Okay, so it looks like x minus 3. Looks like this one right here when x is less than negative 2. So what I'm going to do is I'm going to take this, and it's like we have an invisible line here at negative 2. And we're going to erase either the left side or the right side. Well, this tells us to keep when x is less than negative 2. So I'm going to keep the left side. That's where it's less than. So I keep that piece right there. Okay, now this other one. This is true when x is greater than or equal to negative 2. So again, same type of thing. I go to where negative 2 is. And there's like a visible line here. And I'm going to keep either the left side or the right side. Well, this is where it's greater than, so I'm going to keep the right side. Yeah, I'll try it again. And we'll keep that piece right there. Okay. Now x is less than negative 2. That doesn't include negative 2, so this is going to be an open dot here. Now x is greater than or equal to, that includes that, so we're going to put a closed dot right there. Okay, step 3. We're going to merge into one graph. We want to merge that into one graph. And this is just sketching. I mean, don't, at least in my class, don't spend a huge amount of time on it. So this would be that piece, and then this one would be right there. So that'd be your answer. Let's take a look at how to do this on the calculator. And let me write it over. I got f of x is equal to x minus 3 and x plus 1. X is less than negative 2 and x is greater than or equal to negative 2. Okay, the key to graphing these is put parentheses around x minus 3, put parentheses around x plus 1, and put parentheses around your conditions like that. And then we're going to put this on y1, we'll put this on y2. Now on the T83s, these won't look very good. And you may find it easier just doing by hand than to fool with technology in this case. Usually I'm pretty big on calculator, but not sure if these add very much. Press y equals, press clear. Okay, so I do my beginning parentheses, and then I got x minus 3. Put a closing parentheses, beginning parentheses, x, and then next one is less than. Where you find less than is underneath the test menu. So I'll do second math, and less than is my fifth one, so I'll press 5. And this would be negative 2. Close parentheses. Then I'm going to do a down arrow. And do a beginning parentheses, x plus 1. Close parentheses, beginning parentheses, x, and this is greater than or equal to. So I go in the test menu again. So I do second math. Greater than or equal to, boy, my eyes are bad. I think that's 4. And then I'll put in a negative 2. Close parentheses. And then graph. And more precise than what I came up with, but that's your answer. The one thing it doesn't give you the open and closed dot. And you have to recognize when to put that. Now, what's wrong with the T83? It puts a vertical line on there. So if you exclude everything except for that vertical line, then basically you have the same graph. Well, let's take a look at another one by hand. And then I'll try to remember if I remember how to do this one on the calculator. It's a little bit tricky. Okay, so I got negative 2x, and x squared plus 3. This is if x is less than negative 2. This one if go from negative 2 to 0. And this one where x is greater than or equal to 0. Grab a drink. Okay, first thing I'm going to do is graph each piece separately. So look at y is equal to 2, y is equal to negative 2x, and y is equal to x squared plus 3. Okay, y is equal to 2 looks like this. Y is equal to negative 2x. Looks like this. And y is equal to x squared plus 3. Looks like that. Okay, now let's apply our conditions. Okay, so y is equal to 2. It looks like that when x is less than negative 2. So I come over here. Here's negative 2. It'll look like that when it's less than negative 2. Now it's less than, which means this is an open dot. Okay, so it looks like this between negative 2 and 0. And I didn't draw that real good, but what I'm doing is at negative 2, if I put negative 2 in here, negative 2 times negative 2 is 4. So I know this is a point. And if I put 0 in, that'll give me 0. So it's going to look like that right there. So it should have been a little bit more of an angle here. So again, we're keeping the part of the graph that's between negative 2 and 0. Now negative 2 has a less than or equal to, which means this is solid. And this has a less than, which means this is an open dot. Now this one looks like this when x is greater than or equal to 0. So we're going to keep where x is greater than or equal to 0, which is the right side here. It's greater than or equal to, which means this will be a solid dot. Okay. Then step 3, merge those into a single graph. So we have this piece, and then we'll have this piece, and then we'll have that piece right there. And that's our answer. And okay, the key on this to plug in your calculator, and actually let me just write it over. I'm out of space. So I got 2, and this will be x is less than negative 2. And notice I put parentheses around 2. I put parentheses around x is less than negative 2. Then we got negative 2x, parentheses. And see how this is negative 2 is less than or equal to x is less than 0. What this is saying, if I cover up the less than 0, that's saying that x is greater than or equal to negative 2. So So greater than or equal to negative 2. I'm reading it backwards. X greater than or equal to negative 2. And if I cover up the negative 2 and the less than or equal to, the last part, we just got x is less than 0. That's what that's saying. And that's how you have to put it in your calculator. So it's kind of a pain. That's what I say. It's almost as easy to just do it by hand. And then this other one is x squared plus 3. And then parentheses around it. And then x is greater than or equal to 0. Well, this one I'll put in y1, this one I'll put in y2, and this one I'll put in y3. So let's look at this on the calculator. Press my y equals, I press clear on the first line, down arrow, press clear in the second, get that all cleaned out. Okay, go back to y1. So I have beginning parentheses, 2 closing parentheses, beginning parentheses. X is less than, so I do x, go to my test menu. Second math, less than is 5. Mr. Magoo says. And then negative 2, closing parentheses, down arrow, beginning parentheses, negative 2x, closing parentheses, beginning parentheses, x is greater than or equal to negative 2, so I do x, go to my test menu, greater than or equal to is the fourth one, negative 2, go back in my test menu, second math, right arrow over to logic, and I want to choose and, which is my first one. And x is less than 0, so I do x, go to my test menu, less than was 5, 0, closing parentheses, down arrow. Okay, and then y, it's x squared plus 3 inside of parentheses, so beginning parentheses, x squared plus 3, closing parentheses, beginning parentheses, x is greater than or equal to 0. So x, go to my test menu, second math, greater than or equal to is the fourth one, 0, and then closing parentheses, and then graph. And of course I've wiped out my graph, but that gives us our same graph. It doesn't do the closed dot and the open dot, and it does look pretty bad on T83. It has those vertical lines, and in some earlier models of T84 it does that too. But anyway, that's how you plug in your graphing calculator. Now be sure, once you get that all done, and once you're happy with it, assuming you like to use technology for that, press your y equals and press clear on all 3 lines. So press clear, down arrow, clear, down arrow, clear. Love when the graphing calculator makes your life easier, but I'm not sure if this actually makes it any easier. It might make it a little bit harder, which goes against my grain. And I believe we're all done with that section. Yes, indeed we are. So I'll go ahead and finish the recording here.